The TLC59711 is a nice little constant current PWM driver for LEDs, and especially RGB LEDs. It is especially useful as it is very easily controlled with just 2 digital pins from an Arduino, and there are plenty of libraries that exist for it. It is constant current, which means that you don't need any current limiting resistors on the LEDs, and that allows you to use a current set resistor on the current reference pin of the chip to set the amount of current that goes to the LED, and which controls the brightness. The brightness is of course adjustable with the PWM as well, but the constant current sets a sort of baseline for the current that goes through your LED. In this case, I have a 51 kilo ohm resistor in here, and that is setting the constant current to 1 milliamp, and you can see as it changes through each red, green, and blue color, it draws 1 milliamp, and when it switches to white, it draws 3 milliamps. If you have an application where power consumption is a concern, but at the same time you want the user to have an option to have brighter LEDs in general, you would have to, normally, with this chip, simply have different brightness settings, where in the low power mode you just use smaller brightness settings on the PWM data you're giving to the chip, and then when you want a higher brightness mode, you then just send higher brightness settings as the digital data to the chip. But that kind of limits you because you're kind of having to divide it up. If you could change the current set resistor though, you could get around this. And that's exactly what you can do. All you have to do is you have to add a single transistor and a resistor, which allows the current set resistor to be changed. And I'll show a schematic for that in a second. But here you can see I have a switch, which is currently off, so the only resistor that the current reference pin is seeing is the 51 kilo ohm resistor, which sets it to 1 milliamp. However, if I switch this switch, it flips a MOSFET, which puts a 12 kilo ohm resistor in parallel with the 51 kilo ohm resistor. And that means that the current reference pin is seeing a resistance of about 10 kilo ohms, which sets the current to about 5 milliamps. And we can see that the current goes from 5 milliamps to about 15 milliamps when it's displaying white. And nothing in the Arduino software changed. You could implement this without a switch and instead use another single digital pin from your Arduino to change the power mode by pulling the MOSFET either high or low. So here I have a schematic of how this circuit works. We have this goes to the current reference pin, and so normally when this MOSFET is off, this part of the circuit is completely gone, and all that the current reference pin sees is the 51 kilo ohm resistor, which sets the current to 1 milliamp. However, when the MOSFET is turned on, this 12K resistor is put in parallel, which causes the current reference pin to see a resistance of about 10 kilo ohms. Given that we have the resistance for the low current setting, which is our 51 kilo ohms, and we know the resistance that the current reference pin needs to see for our higher current setting, we can calculate the second resistor that we need put in parallel with the first in order to get our desired resistance using the parallel resistance equation. The resistance that we need to use on the current reference pin is given by the voltage at the current reference pin divided by the maximum current we want through our LEDs, times 41. And in this case, the current reference pin voltage is almost always 1.21 volts. And so to get our 51 kilo ohms, we take 1.21 divided by 1 milliamp times 41. And to get our 10 kilo ohms, or thereabouts, we take 1.21 volts divided by 5 milliamps times 41. So that gives us the values we need for R low and R high, and so we can calculate the resistor that we need to put on the other side of the MOSFET to give us our resistance. Here we have a close-up of the circuit with the current reference pin seeing the 51 kilo ohm resistor because this MOSFET is off, because the switch is off. Here we have our 10 kilo ohm pull resistor that just pulls the gate of the MOSFET down to ground when the switch is off, so that way it's not left floating. Then we have our 12 kilo ohm resistor that is switched in parallel with the 51 kilo ohm resistor to give us the desired 10 kilo ohms for the higher current setting. So we can see when I switch on the switch, we get our brighter LED as the current limit of the TLC59711 has changed. And of course, the switch could be replaced with simply another digital pin of your Arduino or any other source of a digital 1 or a digital 0 for the MOSFET to operate with. So there you have it, a simple way to adjust and get higher brightness and lower brightness settings with a TLC59711. And you could add more than just one extra current setting. You could have 3 or 4 or however many you want. All you have to do is you have to add an extra transistor and another resistor to put in parallel with the main current reference resistor. You just need to make sure that the main current reference resistor is the one that is associated with the lowest current setting. In this case, that's the 1 milliamp setting. And then you figure out what resistor you need to put in parallel with that to get your higher current. So you're always switching in parallel, so that way you always get a lower resistance, which gives you a higher current through your chip. Thanks for watching.